Okay, so now I want to go over solid uh, modifying options. These are things that are going to modify existing solids. Instead of having to create a bunch of new solids, you can modify your existing stuff. And so we're going to start off with one of the most popular ones, one of the most common ones that you're going to use, which is union. Union and subtraction are going to be used, I'd say maybe 80% of the time of stuff that you're going to do, and maybe slice as well. So let's see what union does. Union is just combining two different solids. Okay, so I'm going to have two rectangles here that overlap, and we're going to extrude them so you can see how they overlap. Now what union does is combine these two into one solid, and then the intersecting lines will disappear because they will now be one solid. So let's do that now. You union by initiating the command and then selecting all the objects you want as part of the union. And there we go. There's our combined solid, and the intersecting lines have disappeared. The objects don't have to be connected, but they probably will be. A union still technically works this way. These are still one, in the eyes of AutoCAD, these are one solid. But they're most likely going to be overlapped. They also don't have to be in the same plane. They can be kind of offset. However you want your solids to be union, they can be combined and treated as one solid. Okay. The other really important aspect here is layering. When you layer something, let's say I've got layer 1, which is a red color. I've got layer 2, which is a yellow color. Let's put one box on layer 1, one box on layer 2. It follows an order of operations. Okay, so when I do a union, if I select my items sequentially, it takes whatever the source object is and makes that the layer. We'll go the opposite direction. If I want this one to be first and then this one, it takes that layer. When selecting both, it takes the original object. Okay? Kind of like the one that's older in the draw order. So just kind of keep that in mind, because when you're unioning objects that have different layers, it's going to assume one of the layers. And if you want to make sure that it's going to be that layer, like if I know I want everything to be on layer 2, if I'm unioning multiple objects, click the object with layer 2 first, and then click everything else you want to union to that, and you'll assume that layer 2. So, all right. So that's union. Now subtraction is the opposite. Subtraction is removing this volume entirely and removing one of these objects in the process, because we're taking away. What's going to happen is I'm going to let's do a subtract. I'm going to select the object that I want to keep first. Okay, the object I want to take away from. This is the object I want to keep. Enter. And then this is the object I want to take away. Not only will the object disappear, but the intersection between the two solids will disappear as well. That being said, this shape can really be whatever it wants. It can be whatever size it wants, because the only thing that matters is where they overlap. This can be a massive object. It doesn't matter, because when I do a subtraction, it still only removes that one corner. So really, subtraction, the only thing that matters with subtraction is how much you have overlapping or interfering. And since we're talking about interfering and interferences, you have something called intersect. Now, intersect is kind of like a weird hybrid between union and subtract. What it does, it's like a super subtract. What it does is it takes both solids and leaves behind the area that they have overlapped with. This is the intersection of both solids. So if you ever want to get this, which is the intersection of two solids, you can get some more complex shapes that way. I could have a sphere right here and say, oh, I want an intersection between these two things, and all I got is a corner piece there. It's pretty neat to use interference in that way and in interesting ways. Don't confuse that with interfere, which doesn't really work that way. It just shows your interference between the two. It's like a clash detection in a way. So it's not really about actually modifying objects. So that just knocks out interfere right there. It just, because it creates a temporary 3D solid from the differences between two 3D solids. So it's more like clash detection, just showing you where they overlap. Okay, without actually, you can do this before you do it intersect, so you can see what the result's going to be. Okay, now let's get to slice. Now slice probably could have its own video if it needed further explanation, but I'm going to try to explain this as easily as I can. Slice is meant to literally slice an object into pieces, whether it be in half or multiple pieces. I could have, a slice line here and a slice line here. You don't need to have lines, but it's just a way for me to pick a starting point. I could do it at the center of this, right? And I'll choose I want to slice right down the middle. Or I can use one of these lines and say I want to slice here, and then I want to slice here. You can also slice by object. But when it asks you planar object, it won't really take this. You can't do a line. It's looking for a closed boundary, a circle, ellipse, arc, 2D polyline, 2D spline. You might be able to turn this into a, let's see. I have not tried this. I've always used a closed boundary. I actually don't even really do this option very often. But let's say we have a P line. This is not a P line. Actually, it is. So let's do a slice and do it by object. And see, it's not doing it here. Object. Keep both sides, and it's not really working. And probably because this needs to intersect. Let's try this one more time. Pick my object, and it's still not working. So again, I don't really prefer this method because it's wonky. I really just like picking my points. It's so much easier to slice along this. Just pick your object and slice this way, slice this way. You pick multiple objects if you want, or you can just pick one object and slice. Now, when you slice, let's start from the beginning here. When you slice, there is an option it always asks you. Specify a point on the desired side or keep both sides. Now, I typically keep both sides all the time, just because sometimes your cursor placement can be in the wrong place. I can pick this side and it only keep this half, right? But sometimes when you're cutting more complex shapes, you're not really sure if your cursor placement is in the right location, and you might wind up picking the wrong side. Then you got to undo and redo your slice command. It's just easier to me to slice it and then keep both sides and then just go back and erase the side that you don't want. Okay, now what happens if I want to cut this along this path? Like if I want to make a slice like this is a slicing plane. You would think that I can just say slice and click this. It doesn't work that way. You actually have to change your UCS to the front, because what happens is, imagine this cutting plane like this, okay, on the edge. If I move this cutting plane here, that's the same as me doing this, right? Slicing along. In this current UCS, which is like UCS world, if I move this, oops, like right here, we'll put it right here. You can see, oops, I did not put it there. And it's still not. Let's do this. There we go. You can see how it's right on the edge, right? If I do a slice and I try to put the slicing plane here, it's not going to do anything. And it's not doing anything because it's still trying to slice downward. Again, imagine a big knife, like imagine this is a big old knife, okay? And we'll make it look a little fancy. We'll do a little fillet. Oh, it's not. What's the distance on this thing? Okay, well, I'm getting sidetracked here. Imagine this knife is basically cutting down, right? Down. That's what I'm doing when I have this top UCS and this slicing plane. I'm cutting down. I'm not cutting across. For me to cut across, I need to change my UCS to front. Now, when I do a slice and I cut across, there's my slice. Because now what I've got, oops, here's my new knife. I've got my knife doing this, okay, when my UCS is to the front. If my UCS is to the left, I'm going to rotate this, then my knife is doing this, okay? So if your slice is not coming out the way you want it to, it's probably because your UCS is the wrong orientation. And it can take some time to get used to the correct orientation, but just keep that in mind. You know, imagine a knife that's vertically oriented with the Z-axis, but, you know, rotates. So like in this one, I've got this knife that does this. And see how it's vertically oriented with the Z-axis and it's horizontally oriented with the X-axis? So it's going to slice along this way. If I rotate this, meaning if I were to slice along this Y-axis, it rotates. I could even do this at an angle. I could rotate this 30 degrees, right? And watch this. Let's see where my thing is at, right? Kind of look how it overlaps. Let's go to a plan view. Say my knife was like this, right? My knife is now going to cut downward if I do a slice. I can actually trace this slice. Watch this. And there's my slice. As if my knife were cutting straight down like that. Okay? The knife moves across the Z-axis, but it needs to be pointed somewhere on the X and Y axis. Okay? Moves along the Z-axis, pointed somewhere along the X and Y axis. Okay? Hopefully that concept gets through, because it can be kind of confusing on how things can slice. All right. The last thing I want to go over real quick is the shell function, which I don't really use very often, but you might find some use for it. And it can be also kind of a little bit confusing, but I'll try to get through this as quick as I can. With shell, what it does is hollows an object out, giving a dimension that you give it. So let's say that I choose this object, and it says I can remove faces. I'm not going to do that right now. But what it's going to do is essentially offset the inside of this given a distance. I'm going to give it a distance of 1. That might have been too big, too small. Let's undo it. Let's do a bigger shell of like 3. So we go to shell again, or I'll do a shell of 5. Shell, distance 5. Okay. What it's essentially done is offset every edge and hollowed out the interior. And how do I know that it's hollowed it out? Well, if I slice this, like we talked about earlier, and then I change the visual style, you can see it's been hollowed out on the inside. Okay? The thing is, you can get more interesting shells when you start removing faces. Let's say I want to punch a hole through. Think of a shell as, when you remove faces, think of it as a side that you want to see through. So if I want a hole right down the middle of this, I could do something like draw a rectangle, offset 5, extrude it, then subtract it. Now I've got a hole. Okay? Or I can make a shell. Let me go to the shell again. Oh, my line is still there. Let me go to the shell. Okay, now it's asking me to remove faces. I can click the top face. Even though it didn't really look like it did anything, it says 1 face found, 1 removed. Okay. Orbit around, click the bottom face. Same thing, 1 face found, 1 face removed. Enter, choose that shell distance, and now it's got a hole. Because what it essentially did is it's choosing to not offset those edges. Instead, it's just allowing the shell to go through. I could choose to remove the top, the sides, the front, and the bottom, and be left with what looks like an L shape. So watch, I'll do this little shape here. Let's bring this out 5. Bring this back 5. And what you're going to see is a shape that looks like this, only extruded. So I'm going to say shell. I'm going to remove the top, the left side, the front, the right side, and the bottom. Offset distance of 5. Oh, I wasn't supposed to remove the bottom. All I was left with was the last face, so that was my mistake. Let's do this again. Just the select it and remove just the top, the side, the front, and the right side, in a distance of 5, and there we go. Now we're left with this little L-shaped object. You can change the distance to whatever you want. I can do this again. Remove, 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 and choose a distance of 15. Now it's much thicker than my original profile. So shell can make holes and things. I can do a circle and say, oh, I want to make a shell of this, and remove. Oops, let me do a shell again, and remove the top, remove the bottom, and say I want to remove with offset of 10, so a wall thickness of 10, and there I have like a pipe. But you know, you wouldn't really do it for something this simple, because if that was the case, if that's what you really wanted to do, why not just offset 10 and do a press pull inside this boundary? Just as easier to me. So I just want to show you what the function does. You might find interesting ways to do it. Consider it like a way of offsetting edges or faces, and and hollowing things out. So that's the shell function. And that's pretty much it for what I want to show as far as solid modeling, like the main solid editing functions. There are some other ones I want to get to with edges, and I'll do that in another video, and some of the various face functions that I'll get to right here that are less used but are still available to you. But for what you're going to use a majority of the time, it's going to be up in this area.